Hey, how you doing?
Oh, good. How are you?
Good. Ready to teach about density?
Yeah, you ready to learn?
Oh, yeah. I'm feeling good today.
Oh, that's good. Good. So, density. We want to learn a little bit about what the term density means, okay? Density, sometimes you hear people use the term density, but they really don't know what they're talking about, and they kind of just refer to density as mass or something. But density is a relationship between a material's mass and its volume. So density equals the mass of the material divided by volume. Typical units in chemistry class are grams for our mass and milliliters for our volume. Or if you're talking about a gas, it'll be grams per liter simply because gases are much less dense. You need a whole liter of them to get any significant amount of mass. Okay, but again, density is a relationship between mass and volume. So sometimes I have something like maybe a favorite bead, and I would like to know what my bead is made out of. So this is a fancy bead. I want to know what my bead is made out of. I can find out its mass pretty easy. Just put it on the scale and weigh it, right? But I can't necessarily find out what its, what does it say the mass is here?
5.96.
Good, 5.96. But I can't find out what its volume is very easily if it's not a perfect sphere or a nice cube, right? But one trick I can do with anything is you can put it into water and see how much water it displaces. So if I have a volume of water here at 10.2 milliliters, and then I stick my bead inside here, the bead goes down, displaces the water, and the water rises to 12.3 milliliters. Okay? So from that, I can know that the volume of the bead is the difference between 12.3 and 10.2, right? Okay? So 12.3 minus the 10.2, we got 2.1 milliliters. All right, 2.1 milliliters there. This is 5.96 grams. So if I want to find the density is, again, the relationship between what?
The mass over the volume?
That's right. So 5.96 divided by my 2.1, my grams per milliliter, that's going to be my, my density, which here is 2.83809, but I only get two significant digits because my volume here only has two significant digits, right? Okay, very good. So that is our density, grams of material per milliliter of material. Let's see if we can further clarify our understanding of density with some problems here. Here we have a sample of two metals, X and Y, and it says that they have the same mass. So let's draw a little picture. Here's a mass of metal X. Here's a mass of metal Y. Same mass, but X has a smaller volume. So this one looks like it has a smaller volume there. So we'll say X has a smaller volume. Well, if they have the same mass, but X has a smaller volume, that means that X is more dense. Can you see that?
I don't think that's intuitive to me.
All right, so maybe it'll be helpful if we write down some numbers. So like, let's say that X weighs 10 grams. How much does Y weigh?
5 grams?
No, it says that Y and X have the same mass.
Oh, 10 grams.
Yeah, 10 grams. Now, let's give this maybe a 10 milliliters. All right, and X had a smaller volume, right? So let's give that 5 milliliters. All right, so we have a situation here. We just made those values up, right? But we can identify the density usually if we think about it closely enough. Here, our density is grams per milliliter, 1. Here, our density is 2. Now, these are just made-up numbers, but because the volume here is smaller, but the mass is the same, the density of X is going to be higher. Okay, we don't know exactly how much higher because we made these numbers up, but it's going to be higher. Okay, very good. Here's another problem.
Is this the same problem?
No, it's not quite the same problem.
Oh, are you sure this is a different problem?
Yeah, it is. Look closely at it.
Okay, so this time they have the same volume, but they have different masses.
Yeah, that's right. Right? So, can we figure that one out based on that information?
I don't know. Let's see. We have a sample X and Y, same volume.
So I'll draw them here for you. I tried to draw them there the same volume.
Let's say that's 10 milliliters.
Okay, so they both have 10 milliliters in this case, right?
Yeah.
Okay, so if they both have 10 milliliters, what do we know about their mass?
Y has less mass.
Y has less mass, so let's say this is 5 grams. Is that okay?
Yeah, and X can have 10 grams. So then X has a density of 1, and Y has a density of 2.
Density of 2. Don't you put grams over milliliters?
Oh, yeah, so it's half density of 1.5.
Very good. So again, we see that X has a larger density. Okay, very good. Third one.
Again?
Yeah, third one.
Okay, so X has a smaller volume this time, and Y has a greater mass.
Very good. So X, smaller volume than Y, and Y has a greater mass. So do you want to give me some masses?
Y has 10, X has 5.
Okay. How about some volumes?
Well, the volume isn't the same and the mass isn't the same. I don't think we're going to be able to do this one.
I think you're right. If this is 10 milliliters and this is 5 milliliters, then we would say, oh, they're similar. But all this has to be is less than 10, so this could be 1 milliliter. In that case, it would be higher density. If it was 5, it would be 1, right? So you can't tell. You can't tell which one is going to have a greater density here. Very good. Take a look at that one if you don't understand that, and keep working it out in your mind. But we can't determine this sort of scenario. All right. Now, densities are an example of a measurement that can act also as a conversion factor. Because when we get information about the density, for example, the density of blood, we say is 1.05 grams for every 1.00 cubic centimeters, or cc's, or milliliters. Cc's means the same as milliliters, right? Didn't you say you were going to try to go into pre-med?
Yeah.
So you have to know what they mean when they mean cc's.
It's just milliliters?
Yeah.
Why do they use cc's?
I don't know. They still do, though. Okay, so here's an example. Crash sounds from the lab. A large vial of mercury is fallen and broken. It's spilled 2 quarts, but they want to know what mass of it is on the ground. Okay, so we're going to use our method with an equal sign, and we're going to choose our units to the right. And we're going to start with 2 quarts of mercury and see if we can get to what? What do we want to get to?
They ask for the mass. So like, you mean like grams of mercury?
All right, grams is a mass unit, right? Very good. And we want to be specific there, grams of mercury. Very good. So 2 quarts, what goes down here?
We need to get rid of quarts.
So quarts goes down here. And what can we convert quarts to?
Well, you said that quarts the problem tells us that quarts is 1.0567 quarts per liter.
Very good. So I'll go to liters. 1.0567 quarts for every 1 liter.
Now you got to go to liters to something. And they gave us the density in grams per milliliter, so maybe we go to milliliters.
All right. Very good. 1,000 milliliters per liter. Is that right?
Yeah, that's right. And now,
What goes down here?
now we go milliliters down there for sure, because we don't want milliliters.
Good, yeah, because we're getting rid of our units that we don't want, right? But what goes up there?
I don't know.
What would we like to go up there?
We'd like the grams of mercury. Do we know how many grams per milliliter?
Yeah, what do you call that? The grams per milliliter of something.
Oh, that's the density.
That's right. So it's 13.69 grams per 1 milliliter. So we're in grams, and we got rid of milliliters there. Okay, very good. So our, see, maybe yeah, we got it right there for ourselves. Our 2 divided by 1.0567 times 1,000, or divided by 10 to the minus 3, same thing, times 13.69 gives us 26,000, or 2.6 times 10 to the 4th grams of mercury. All right, very good, fabulous. So here's one extra problem that we can work on. Let's use the factor labeled method to convert area in feet squared to square meters. Okay, same thing. What do we start with?
Equal sign.
Very good, equal sign.
Breathe out.
Good, now what?
To the right of the equal sign goes meters squared.
Meters squared. And what do we start with?
124 feet squared.
Very good. Where are we going to go from feet? How are we going to get to meters?
I don't know. I know feet to inches. That's about all.
Very good. So we'll go there. Feet to inches. How many feet per inch, or how many inches per feet?
12 inches per feet.
Okay, very good. But if we just put 12 here and go 1 foot like that, we're not quite getting rid of all the units, right? Because we had 12 feet squared, and we have feet here. Does that make sense?
Yeah. So what do we got to do?
Well, we need to square this, right? Square this. And that means we also need to square these values down here. Okay? So now I can go from inches squared to what?
Inches to centimeters squared?
Good. Why did you choose to go to centimeters squared?
I know how many centimeters there are in an inch. I remember that. 2.54.
Okay, 2.54 centimeters per inch. And I'm going to need to square this because these are centimeters squared. All right. Now I can go from centimeters squared to meters squared. I know that one. 100 centimeters squared for every 1 meter squared. All right, there we go. So our answer, 124, divided by, no, I don't need to divide it by that 1. I can just multiply it by 12 twice. That's 12 squared. Multiply it by 2.54 twice. It's 2.54 squared. And then divide by 100 twice. Okay, 11.5. That's how many significant digits. So 11.5 meters squared. Good job.
Great. Thank you.